Okay, I'm going to do a little review of factoring because some basic factoring I think is what a lot of us are having trouble with. I'm going to go over three different types of factoring. The first one today we're going to do is factoring when we have a common factor. So common factor, take out the greatest common factor. And there's a couple of ways to do this. Probably the most common way that we end up doing is, well, first of all, I'm going to do it the long way. One of the ways we could do this is to break each of these numbers, these terms. There's two terms here. This is one term right here, and this is another term right here. If I break everything down to prime factors, it would look like this. Let's see there. So I would have 2 times 2 times 3, that's 12, and then x to the third is x 3x's and y to the fourth, and then 2 times 2 times 2 times 2, that's 16, x squared y to the sixth. So that's what we would have. What we would do for this is to take out the common factor. So I would look at this and say, what are some of the common factors, numbers that are in both of these? Well, there's a 2 and another 2 in this one, so I'll write down 2. There's another 2 here, I'll write that down, and that's going to be out here. These are numbers that are going to go in front of the parentheses, and then I have an x, and then another x. Okay, and I'm just going to 1, 2, 3, 4 y's. 1, 2, 3, 4 y's. So that's going to be 1, 2, 3, 4. And then what's left over after I take out is 3x here. And then the plus sign. And then 2 times 2 is 4. 4y to the second. Okay, and then when I simplify that, that would just become 4x to the second, y to the fourth, parentheses 3x plus 4y squared. That's the long way to do it. I would suggest eventually we kind of look at it maybe a different way. Basically, what I look at when I do this is I know the answer is going to look like this. It's going to be in this form right here. Something in front of the parentheses, that's the common factors. We always look for that first anyway. So what I would suggest, well, let's look at the greatest common factor of 12 and 16 is 4. What number goes into both 12 and 16? 4. So that goes in front right here. And then the greatest common factor of x cubed and x to the second is x squared. So the x squared goes in front. And then greatest common factor of y to the fourth right here and y to the sixth here. The greatest common factor is y to the fourth. That goes in front. And then what's left over is what would multiply to give us 12x to the third, y to the fourth. Basically, I'm dividing out a 4x squared y to the fourth. So 12 divided by 4 is 3. X to the third divided by x to the second is x. Y to the fourth divided by y to the fourth is 1. So I get that. And a similar thing here. So that would be our final answer. So greatest common factor is just the first thing we always look for is see if we find common factors. And the more you practice it, the better off you're going to get with doing it. Okay, another type of factoring that was pretty common is quadratic trinomials. I'm going to do two types of similar problems here. When I look at this one, I look at this and I say, okay, here's a quadratic trinomial. Now we're just going to deal with ones when the leading coefficient is 1, which is a little different and easier than some of the other methods. Okay, the first thing I would suggest when I look at this is I will always look for common factors, and there are none. So now I go to the next step, which would be to know what it's going to look like. There are no common factors, so the answer should look like this. Two sets of parentheses. And then I look at this x squared. To get x squared, these first two numbers, whatever is here and whatever is here, will multiply to get x squared, so it's going to be x times x. And then the last two numbers here have to multiply to get 24, because when I do FOIL, I'm going to say x times x, that's x squared, and then I'm going to have other terms, and then the last two terms will be these two. So these two numbers have to multiply to get 24. And I wrote here that they have to add to get 10, and that's because this is a plus sign. So what I do then is I figure out what are the multiples of 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. Those are the only ones we're going to look at. I'm not worried about this minus sign here or anything like that for now, just to make it easy for myself. I'll deal with that at the end. But I'm looking for numbers that multiply to 24, this, there's 4 of them, but also added 10. That's just this one right here. So since 4 and 6 are the numbers that multiply to 24 and also add to 10, those are the numbers that are going to go in. So it's going to look like this. And the last thing I deal with is my plus or minus. And this sign right here, since that's a plus, it tells me they have to be the same sign. Either because it's positive 24, it has to be, last two numbers must be the same sign, either positive times a positive or negative times a negative. So it's either going to be plus plus or minus minus, and that's determined by this one right here, since the middle term, negative 10, is negative, both signs will be negative, and there's my answer for that problem. Next, I'm going to look at a really similar problem, which is almost the same. The difference now is this is a negative 24, which is going to change the answer fairly dramatically. So we know it's going to look like this because there's two factors, two binomials. That's what quadratics will factor to be. The first two have multiplied to get x squared, so that's going to be like that. And now I'm looking for numbers that multiply to 24, but in this case they're going to subtract to get 10. So I go through the same steps I did before in listing my multiples of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And then I say, do any of these pairs subtract to get 10? Last problem, when this was a plus sign, they added to get 10. This one, they're going to subtract to get 10. So I look at that and I say 2 and 12 are the numbers that subtract to get 10. So I put the 2 and the 12 in here. And now I go through the similar process. It's a little different though, because this is a negative 24. Because that's a negative 24 right here, the numbers have to subtract to 10. And to get a negative number, I'd have to multiply. The last two numbers must have opposite signs, because to get a negative, I have to either have a positive times a negative or a negative times a positive. So it's either going to be plus and minus or minus and plus. And when that's the case, what we do is the middle term is negative. The bigger number will get whatever sign happens to be here. So this is what would be here, because the bigger number is negative. The negative goes with the 12, and the 2 goes here. Now the last type of factoring that we're going to look at is difference of squares, and that's a special type of factoring. Whenever you have two terms, always look first for common factors, and there aren't any. But when there are, we look at these numbers, 9 and 25, and those are kind of special numbers. Certain numbers, special numbers are that we look at are perfect squares, like 9 because it's 3 times 3. This is 5 times 5. Other numbers like 49, 81, 64, 121, 144, those are all perfect squares. When you see those, start to think of that possibility of being perfect square. So since there are no common factors, we know it's going to look like this, even because it's a quadratic. But we also know that we look for no common factors, look for difference of squares. We have difference of squares. This is the formula for difference of squares. A squared minus b squared will be a plus b times a minus b. In this problem, 9x squared, that's the first term, is 3x times 3x. And 25 is 5 times 5. So it fits this formula, difference of squares. 3x times 3x, which is 3x squared, minus 5 times 5, which is 25, 5 squared. So then the answer will just be A, which is 3x plus 5 and 3x minus 5. Okay, I hope this helps a little bit. Factoring just takes practice, so the more we practice, the better off we're going to be.